Hi class. So we're talking about dew point temperature and just reminding ourselves of the definition of the dew point temperature. It is the temperature to which you have to cool the air in order to reach saturation. So, you're probably looking at what I've got down here and it's like, well, we already did this table, completed this table. Why are we looking at it again? We can use this table to demonstrate the concept of dew point temperature. So again, dew point temperature is the temperature to which you need to cool the air to reach saturation. So when we were looking at this table originally, we gave initial conditions, temperature 20 degrees C, therefore, again, based on the saturation mixing ratio table, 20 degrees C, it has a saturation mixing ratio of 14 grams per kilogram. And I gave you that the mixing ratio was 7 grams per kilogram. So the initial conditions, we started off with a relative humidity of mixing ratio over saturation mixing ratio, 7 grams per kilogram divided by 14 grams per kilogram, gave us initial conditions of 50% relative humidity. Then we cooled the air by 5 degrees at a time, and as we cooled the air, that reduced the saturation mixing ratio. We kept mixing ratio constant, and in doing so, that increased the relative humidity. Okay, and in this particular example, when we decreased the air temperature by 5 degrees to 15 degrees Celsius, that raised the relative humidity to 70%. We cooled it another 5 degrees to 10 degrees C, and that increased the relative humidity to 100%. So by definition, we cooled the air down to the dew point temperature. Okay, the dew point temperature, the temperature you have to cool the air down to in order to reach saturation. Okay, so with the assumption that our mixing ratio it hasn't changed, we could have predicted with the initial conditions what the dew point temperature was going to be. And we do that by looking at this table, and again, we call this the saturation mixing ratio table, but you can also use it for mixing ratio. Okay, so we said before that if you know the temperature, you know the saturation mixing ratio, and that's true. Okay, if you know the temperature, you know the saturation mixing ratio. If you know the temperature, you know the saturation mixing ratio. You can also turn that around and say if you know the saturation mixing ratio, you automatically know the temperature. The table works both ways. Now, you can also use this exact same table for the mixing ratio, okay? Only in this case, if you know the dew point temperature, you know the mixing ratio. If you know the dew point temperature, you know the mixing ratio, and it's the exact same table, okay? Likewise, you could flip around. If you know the mixing ratio, you know the dew point temperature. If you know the dew point temperature, you know the mixing ratio. If you know the mixing ratio, you've got the dew point temperature. Okay, so in our example here, where we started off with a mixing ratio of 7 grams per kilogram, okay, we could look at the what we call the saturation mixing ratio table, but also the mixing ratio table. If we have a mixing ratio of 7 grams per kilogram, then we can automatically determine, based on this table, what the dew point temperature is going to be. It would be 10 degrees C. And sure enough, when we did the calculations, when we cooled the air down to 10 degrees C, that's where we hit 100% relative humidity and hit the dew point temperature, okay? And so, based on this figure, all right, let me write something down for you to keep in mind. Okay, this is the saturation mixing ratio table, and so, and you know this part already. Okay, if you know the temperature, comma, you know the saturation mixing ratio. Okay, so that's what we've been doing all along. If you know the temperature, you know the saturation mixing ratio. Okay, but you can also turn that around. If you know the saturation mixing ratio, you know the temperature. So that's the second part of this. So based on that table, if you know the saturation mixing ratio, okay, then you also know the temperature. Okay, so that's how we had been using it, but now we can also, we figured out we can also use this exact same table for mixing ratio and dew point temperature. If you know the dew point temperature, you know the mixing ratio. And if you know the mixing ratio, you just work backwards and get the dew point temperature. So we can use this same table and we can say, if you know the dew point temperature, so temperature subscript dew point, dP, okay, then you know the mixing ratio. Okay, remember the mixing ratio is the actual amount of water vapor in the air. Okay, and conversely, if you know the mixing ratio, then you know the dew point temperature. All right. Okay, so this is an important table. You don't need to memorize it. If you ever need it for a quiz or whatever, I will provide it for you. So you don't have to memorize these numbers. Just make sure you understand the concept that if you know the temperature, you know the saturation mixing ratio. Likewise, if you know the saturation mixing ratio, you know the temperature. Okay, but you can use the same table for dew point temperature and mixing ratio. If you know the dew point temperature, you know the mixing ratio. Conversely, if you know the mixing ratio, you know the dew point temperature. Okay, I hope that helps.